Okay, 5B. 5B says write, but do not evaluate. That's good news. So we don't have to do computations. An integral that gives the volume of the solid generated when R is rotated about the line y equal 4. Okay, so they're going to take this region, that right here is 4. They're going to draw a line right here. They're going to rotate the region. We don't really care. Let's copy this here. We don't really care this off, what the region looks like. All we care is to memorize and understand that because that's the center of rotation, every slice will be a circle with a hole in the middle. We do need to make sure we recognize that the center of this slice is this line. They're just two different views. You can't see the slice over here because the slice is on edge. But that dot, right here in black, if I were to put that dot in the other picture, it would be like right here. If this slice was the slice right here. If we move the slice to say here, now the slice would look something more like this. It has a much larger hole in the center. But the center of the slice is right there, and it's right here. So, whenever I'm trying to find a volume, I focus on the area of the flat part of the slice. To find that area, I have to find this radius. From here to here. Okay, that brown line would be from here to here. So I need that radius. If it were the green circle, the brown line would be like this.
Teachers, thank you for your help today with ticket sales. There are a few extra bagels available in the front office conference room if you'd like one.
It would be right there. So it would be a different radius because the circular slice is of a different size. But it doesn't matter, it's the same formula for the radius. So that brown radius I call the outer radius. And it's going to be 4 subtract y at the top, subtract y at the bottom, f of x. Because remember, we already figured out in part A that this is f. Okay, now the radius here of the hole goes from here to here. That's my inner radius. That's going to be 4 subtract g of x. The same would be true if I were finding this radius. This inner radius is much larger, but it's the exact same formula. 4 subtract g of x. Okay, I'm all set now to write the integral, so I just write it. So part B here. I prefer this method, to be honest. I take the outermost radius, 4 minus f. Make sure that's in parentheses, that gets squared. That gets multiplied by pi. This will compute the flat area of an entire circular slice. Then I go to here. This is the formula for computing the cutout in the slice. I square that, multiply by pi, that computes the area of the cutout of the slice. Be careful with your parentheses again. So this parenthesis and this one, everything inside the orange parentheses is calculating the area of the entire flat circular slice that has a hole in the middle. So it's calculating this area like so. It's not including the hole. You multiply that by dx, you get the volume of one slice. You repeat that computation for all relevant values of x, you get the entire volume. They give 2 points if the integrand is correct. You've got to be very careful. You must have everything, and you must have all the right parentheses. You must have the dx, then you get 2 points. If you have the right limits, and you remember to have pi where it's supposed to be, they give you a third point for a total of 3.